Hello, Algebra 2 folks, and welcome to evaluating trig functions of any circle on the unit circle. So today we're going to talk about what a unit circle is. You need a calculator, a pencil, your notes, and your unit circle chart. All right, let's get started. Before we talk about a unit circle, let's go ahead and review how do we convert. So let's go ahead and take this 30 degrees and convert it into radians. So 30 over 360 would be equal to x radians over 2 pi. Remember, there's 360 degrees in a circle, and there's also 2 pi radians in every circle. All right, now we're going to cross multiply. We would have 360x is equal to 60 pi. Divide both sides by 360, and we are going to get x equals 1 over 6 pi. Or another way we could write that would be pi over 6. Okay, so we want to write the radians next to each one of these degrees on our unit circle. Now you could go through and do that and use the proportions and practice that, or you can use the chart that I came up with. So I want you to take a minute and pause and write these all down on your unit circle chart so that you have them. Okay, and now that you have got those all on there, we will talk about what a unit circle is. This circle is called a unit circle. It has a center of 0, 0. So if it has a center of 0, 0, I can actually make and draw my x-axis and y-axis. There's my y-axis, there's my x-axis. And I can say it has a radius of 1 unit. So if I want to talk about the radius of 1 unit, if I go 1 unit over here, this ordered pair, I can actually put an ordered pair there and call that ordered pair 1, 0, because I came over 1 unit for the x and I didn't go up or down for the y unit. So this ordered pair at 360 degrees would be 1, 0. At 90 degrees, this would be 0, 1. Okay, if I go over to the 180, that would be actually negative 1, 0. And if I go down to the 270, that would actually be 0, negative 1. So these are some ordered pairs that you also want to write on your unit circle that will help us in a few minutes understanding why we would put those ordered pairs there. Okay, so now that you've got your chart filled out and your coordinates there, we will now talk about what a unit circle does to help us. So it has a center of 1 and it has a center of 0, 0 and a radius of 1. And we have been talking about reference angles and reference triangles. And so to understand sine, cosine, and tangent ratios with this circle, we will think about the reference triangle for the unit circle through a general point, x, y. So we've talked about a point that we've made on our terminal side, and usually I've said it's 3, 5, 4, 2, 6, 1. I've given you a value for that. Well, now I'm not going to give you a value. I'm just going to tell you it's x, y. Now, I know that's kind of hard to understand, but at the same time, it's just giving you letters instead of numbers. So I can go ahead and make my reference triangle, drop that 90 degrees down to my x-axis. Here would be my angle, my reference angle, because it's closest to the origin. And instead of putting numbers here, I can just put variables, because this unit would be my y unit. However many y units you would use there, that's what you would put. But in this case, I'm just using the letter. And if you were to come over to where your triangle makes the 90 degrees, that would be x units. And now that we know that a unit circle has a radius of 1, this is our radius of 1, but we're just going to call it r, because that's our radius. Okay? Now, what we can do with that is we can come up with sine, cosine, and tangent based on this unit circle. So if I am standing at the reference angle and I want the sine of theta using this unit circle, then I know that sine is opposite over hypotenuse, which is really the y value, no matter what the y value is, the y over the radius, which is r, because that's the hypotenuse. Cosine is adjacent over hypotenuse, so adjacent would be your x value over r, and your tangent would be y over x, because it's opposite over adjacent. So these are going to help us in understanding and coming up with the values that we need to come up with, knowing that sine is really whatever y is over r, cosine is whatever our x value is over the radius, and tangent is y over x. Okay, when should I use the unit circle? So you're thinking, okay, now I've kind of got an idea of what the unit circle is, but now when do I use it? Well, it is best to use our knowledge of the unit circle when we have quadrantal angles. Quadrantal angles are angles whose terminal side make it totally impossible for us to draw a reference triangle. When we can draw a reference triangle, we don't need to use y over r, x over r, y over x. We don't need to use that because we can see the triangle. But what happens in a unit circle is that when I talk about 4 or 5 different angles, and one of them happens to be 270, which is right here, my terminal side, I can't form a triangle. I cannot form a 90-degree to the x-axis. So with that terminal side not being able to make our reference triangle, we need to understand that there's these angles that don't allow us to make these triangles, and they are going to help us be able to still evaluate the sine of 270. So if I want to take my unit circle here, and using the idea of unit circles, I want to evaluate all trig functions at where my theta is at 270. So I need the sine of 270. Remember, I always told you to line them up. So cosecant is the inverse of sine. So I'm going to line them all up here. Cosine of 270, which is the secant of 270. Tangent of 270, which is the cotangent. Remember, these are inverses of each other. Okay, so now that I have that ready, then what I can do is I can evaluate the unit circle for all 270-degree angles. Well, if I know these ideas of y over r, x over r for cosine, and y over x for tangent, it's going to make this way easier. So I know 270 is at the ordered pair 0, negative 1. Well, what does the 0 represent? It represents the x. What does the negative 1 represent? Oh, it represents y. And what do we know about a unit circle? It has a radius of 1. So all these values are going to be helpful in us finding sine, cosecant, cosine, secant, tangent, and cotangent. So if I want to do sine of 270, sine is y over r. So I look at my y, which is negative 1, and I find my r, which is 1, and negative 1 over 1 is negative 1. And then cosecant is the inverse of that, so it's 1 over negative 1, which is still negative 1. Cosine is x value, which is 0 for 270 over 1, and 0 over 1 is 0. And secant is the inverse of that, which would be 1 over 0, and you can't have a 0 in the bottom, so we would call that undefined. I don't have enough room there to write undefined. Or empty set. You could just do a 0 with a line through it. That means not possible. The tangent of 270 would be your x value, or your y value over your x value. So you find your y value, which is negative 1, over your x value, which is 0. And again, you can't do that. So that would be undefined. Okay. Cotangent of 270 would be the inverse of tangent, which is x over y, which is 0 over negative 1, and 0 divided by negative 1 would be 0. All right, so that would give me the trig functions for theta being at 270 degrees. Now, what would I do if I wanted to evaluate all 6 trig functions at pi over 2? Well, first of all, I'd have to know where pi over 2 is. But you have that labeled on your unit circle. So pi over 2 is actually 90 degrees. So we are going to figure out what all the values of pi over 2 are using the unit circle. Now, 90 degrees, which is pi over 2, has an ordered pair of 0, 1. The x value is 0 and the y value is 1. And remember, with a unit circle, the radius is always 1. All right, so now I can go ahead and find the sine of pi over 2. I can find the cosecant of pi over 2. I can find cosine of pi over 2 and secant of pi over 2. Tangent of pi over 2, and cotangent of pi over 2. Oops, I'm going to have to erase that there. All right, so to do that, I just need to know x, y, and r. So y is 1, radius is 1, 1 over 1 is 1. The cosecant is the inverse, so that'd be 1 over 1 again, which is 1. Cosine is x over r, which is 0 over 1, which is 0. Secant would be the inverse, which is 1 over 0, which is undefined. And tangent of pi over 2 is y over x, which is also undefined because you cannot have a 0 on the bottom. And cotangent would be the inverse, which would be 0 over 1, which would also be 0. So this is what we do. We use the unit circle and those variables to help us find all the trig functions, knowing that the radius of a unit circle is 1. Thank you for taking good notes, and we will come back to practice this again tomorrow.